Welcome back. This video will discuss Python's support for a concept known as object-oriented programming, specifically the creation of new types, also known as classes of objects. Object-oriented programming is one of the main paradigms used to create programs, where a program is thought of as an object containing both state and behavior. Further objects are used for each piece of state, each with its own substates and behaviors. In object-oriented programming, the structure and functionality of an object is defined by its class, which is a template for creating new objects of the type. Python itself is highly object-oriented. Nearly everything in Python is an object defined by some class. Even basic numbers are objects, which contain state and behavior. However, you will often want to go beyond the basic types available in Python and create your own types that match the specific domain you're working in. To do that, we use the class statement. The class statement consists of a keyword, class, followed by the class name that you choose, and a colon. Then you have the indented class body, which will define all of the variables, that is the state, and all of the functions, that is the behavior, that are intended to be used with objects of that class. Let's start to work with objects over in VS Code, where I already created a new folder called example classes, and I've started a new Jupyter Notebook main.ipynv. Here in the first cell, I'm going to create a basic definition of a new class designed to represent a type of inventory item. Class inventory item, colon, indented, and then the keyword pass, which is a placeholder for when I add things to the class a little bit later. Now, new objects are created from classes by using them like a function. For example, A is inventory item, open close parentheses, and I'll print A. So here we can see a new object of type inventory item was created, and this is the default printout. Now A is already somewhat useful. We can use it like a dictionary, assigning whatever names we'd like to the object. For example, A.name is spaceship. A.price is 42. Now, because I'm going to be printing out objects of this type often, I'm going to create a new function to help me print them out in a nice formatted way. Print item, and I'll print a formatted string, item, and then the item.name, a $sign, and the item.price. And because it's a dollar amount, I'll put 0.2f afterwards. And close the formatted string. And I didn't mean to put this colon, so that looks good now. And let's see what print item A does. And we can see it does item is spaceship, and it's $42. But wouldn't it be great if we could force all of my inventory items to have a name and a price? I shouldn't have to add name and price. This is of type inventory item. But right now the class doesn't have any notion that there should be a name and a price. One way we could do that is by creating a new function that created items and required that you provide a name and a price. And so as an example, I'm going to create it up here. I'm going to say def create item. And I'm going to require that you provide a name and a price. And if you do that, I'll create an item to return this inventory item, and to return .name is whatever name was passed in, and to return .price is whatever price is passed in. And I'll return to return the object created back from the function. We created a new inventory item here. Create item car, and I'll give the price of the car as 12. So now let's print item B here. So you can see this function can now be used to create inventory items, and we can still use print item with it because create item assigns name and price, and print item requires that an object A has, or an object of type inventory item has item.name or item.price. Otherwise we get an error. For example, if we tried to create a new inventory item here, inventory item, and tried to print item C, that last one will give us an error because this inventory item has no attribute name because we never assigned it, right? Like we did with A, we assigned name and price. And so creating our own function definition like this that assigns names or prices isn't the most convenient. It turns out Python has an even more elegant way to make this happen within the definition of the class itself. This is known as automatic object initialization. Let's return to the class definition of inventory item. Instead of writing pass here, we can add a special, what's known as magic method, or magic function, sometimes known as a dunder function because of the use of double underscores, called init. So def underscore underscore init underscore underscore, that's the dunder part. Then we write something called our name self, and what self is going to refer to is the object that is created. And then we can put any variables that we want to require you to pass in, or objects we want you to pass in to initialize the object with. So in this case, I'm going to write name and price. And then here's the magic. We assign self.name equals name and self.price equals price. Why is this magic? So let's run this. And we're going to return to this code and try to run it. Okay, actually, I'll return to this code and try to run it. Trying to run this produces an error. It's missing 2 required positional arguments, name and price. Notice it's not missing 3 required positional arguments. And the reason is because self is referring to the object that already got created when this function is called. This is, again, the magic part. Self already exists when this function is called, and so the only 2 that are required are name and price. How I have to use this now is by providing a name. In this case, I'll write spaceship, and a price, 42. Now this runs without issue. This code should still work almost the same way, except for it's going to cause an error on create item because we again used inventory item alone. I'm going to run the code again. We'll get an error, and I'll fix it. Name, price. We no longer have to assign name and price inside create item. It still has an issue because I use C this way, and let's say this is some sort of var 6. And now this code runs without any issue. We can also build functions into the object that automatically get a reference to the object. Again, this will be self when they're used. So let me return back to the class and add another function definition. In this case, I'll add a function that reduces the price of an object when provided a ratio or a percentage. Self percentage. And I'm going to write self.price is self.price times percentage, or a more succinct way to do this would be self.price times equals percentage. I'll run this block, so now the class definition of inventory item contains both init and reduce price. And I'll come down here and write A is inventory item spaceship 42. And I'll also add a.reduce price and provide a reduction, 0.5 in this case. And let's print item A. And we can see that A is an inventory item. It's a spaceship. It started as 42 in price. We reduced the price by 0.5, and and we printed the item, and now it is 21. So how this works is in both init and reduced price case is that these methods are actually named inventory item dot underscore underscore init and inventory item dot reduce price respectively. And they can be used exactly as stated. And so if we wanted to initialize an inventory and item again, we could pass that inventory item and a name and a price. Spaceship 42. Or in this case, we could do A and then a percentage. This works. We can run this code and it executes. This isn't the most elegant way to use those though, but we have an option of running a.reducePrice, or we can write inventory item.reducePrice and pass in A and then the value that we want to reduce it by. Finally, it's extremely common to want to convert an object to a string representation for printing. We have this print item in this case, but we don't actually need this. We can use the regular print. In order to do this, we need to provide a way for the object to convert itself into a string representation. Again, we can use a dunder function, str. Again, you see self here. But in this case, it has no input parameters. Its only job is to convert itself into a string representation. And so we can use the exact f string that we use down here and return that. But instead, this is now self.name and self.price, because that's what the object is called inside this function definition. This is what it's passed in. I'll run this. And now when we print A, for example here, we can see that it prints Spaceship 42 instead of printing that other representation. If we write repr of A, we should be able to get that original print back if we wanted to know the representation of A. And so str of A is now the printout, or we can eliminate the str because print automatically calls str on each of its inputs, and we can see it prints item Spaceship 42. In summary, a class allows you to define a new Python type. When you use the class name like a function, you create a new object of that type, initialized according to the class init function. Objects have their own variables and functions. Much like our discussion of standalone functions, you should try to make classes that are entirely self-contained, where you only need to know the functions and variables that you can use with an instance of the object. You may not find much use of classes at first, while your programs are shorter, but as things become more complicated, it's useful to be able to group code and data together, especially when working on a rich domain with a lot of specific vocabulary for that domain. Lastly, know that we've only scratched the surface of object-oriented programming. What we've talked about is immediately useful, but where the paradigm gets powerful and much more complicated is by introducing inheritance, where you can extend the functionality of existing classes, creating subtypes for objects.